Gosh, I'm hungry.
But wait, you always hear your mom say, wash your hands before you eat, you know, to kill the germs.
I already did, but what are germs?
Germs are these really small things called bacteria. Like, you have to use a microscope to see them.
Yeah, and most of us think of bacteria as a bad germ.
Is there any good germs out there?
Yeah, of course. One's called Lactobacillus GG. You can find it in your intestines and in dairy products like that yogurt.
Gross, there's bacteria in my yogurt?
Of course, it stays alive off lactose, which is sugar, and you can find that in all dairy products.
So there's bacteria in milk and in the cheese?
Of course, you silly goose.
Are you talking about the space shuttle project again?
Yes, I was just explaining to Amber that Lactobacillus GG is a good bacteria found in dairy products and our intestines. I hadn't exactly gotten to the space part yet.
The space part? Now I'm really confused.
Well, here, let me clear this up for you. We're setting our experiment up on the Space Shuttle Endeavour.
Wow, that's really cool. So I'm guessing you all done the experiment, the bacteria that Jay was talking about. The good one, the
Lactobacillus GG. You got it.
What made you not want to do the bacteria?
I said,
Hey guys, well, we found an article on Russian scientists about cosmonauts.
Cosmo what?
Cosmonauts.
That's a Russian astronaut.
Oh, what did the scientists find?
They found that gut flora.
That's our good bacteria, the Lactobacillus GG in our intestines.
Yeah, they also found that the good bacteria decreased over time in space.
Yeah, so the longer the cosmonauts spend in space, the lower the amount of bacteria in their intestines.
Why do they care how much lactobacillus is in your intestines?
Now remember, lactobacillus is a good bacteria. It helps the body fight infections and it helps digest food. So the less bacteria, the more problems.
Why does the amount decrease in space?
Well, we aren't sure that it does decrease. That's exactly what we want our experiment to figure out. We're going to send a sample of Lactobacillus GG onto the space shuttle.
I think it's pretty cool that this is the last flight ever for the space shuttle and the launch is this afternoon.
You're right, Ben. That makes our experiment a part of history. And I still think the experiment is the coolest part.
How are you going to do an experiment in space if you're not going?
Well, we're going to do the same experiment on Earth at the same time. Then when the shuttle comes back to Earth, we will compare our measurements to the space shuttle measurements. This will let us know if lactobacillus grows better in gravity on Earth or in microgravity in space.
Hold on, so how will you count the bacteria? You said it's too small to see.
Great question. Hey, Ben, bring me those Petri dishes. And Cody, get this back to when you're ready.
we're on it.
Alright, there are two ways that we can count the bacteria. One is to grow bacteria on these Petri plates and see how many show up. Like this plate here. These white dots are actually bacteria. Let's see, there's 1, 2, 3, too many to count. Lactobacillus is right here, growing.
The other way is using this machine called a Spec 20. It shoots light through this thing where we put a sample of bacteria. The more light, the less bacteria. The less light, the more bacteria.
That's great, but I still don't understand. How will you know the difference?
Let me make it simple. The space mission is 14 days. Over the time, the lactobacillus will grow. If we send 10 bacteria to space and keep 10 bacteria here on Earth, at the end of the 14 days, we will recount the bacteria. If we got 15 bacteria back from space and 100 bacteria growing on Earth, we will know that the microgravity makes lactobacillus grow slowly. In fact, this example would be twice as slow. Get it?
Yeah, what would it mean if you found that out to be true?
What to be true?
You know, the microgravity slows down the growth of lactobacillus.
I'll take this one, Cody. It means that if the astronauts want to stay in space for longer missions...
Like the one to Mars?
Yeah, like the one to Mars. Well, a mission like that would take like 2 years. So if the astronauts are going to be in space for 2 years, and their lactobacillus levels are decreasing because of microgravity, then NASA will have the astronauts find other ways to put lactobacillus in their body, or they will become ill.
Other ways, like eating more yogurt in space?
Exactly, Amber. We want to see if NASA needs to incorporate lactobacillus into astronauts' diets.
Now that's cool. What time is the shuttle launch? I want to watch this.
At 3:47.
Which means we gotta go get ready.